sensorPower 7, this line defines a constant named sensorPower and assign it the value 7, indicating that pin 7 of the Arduino is used to control the sensor's power supply. sensorPin A0, this line defines a constant named sensorPin and assign it to the value A0, indicating that analog pin A0 of the Arduino is used to read the sensor's output. In int val0, this line declares an integer variable named val and initialize it to 0. This variable will be used to store the analog reading from the sensor. Next is sensorPower output. This line sets pin sensorPower pin 7 as an output pin, meaning the Arduino can control whether power flows to the sensor. In digitalWrite sensorPower low, this line sets the output on pin sensorPower to low, meaning the sensor is initially turned off. And Serial.begin 9600, this line initializes the serial communication with a baud rate of 9600. This allows the Arduino to send data to a computer via USB connections. In int level, this line calls the readSensor function, which returns the sensor reading and stores the return value in the variable level. Serial.print water level, this line prints the text water level to the serial monitor. In Serial.println level, this line presents the value stored in the level variable to the serial monitor, followed by a new line character. And its delay is 1000. This line pauses the program execution for 1000 milliseconds, 1 second, creating a delay between reading. Yung read sensor niya naman is digitalWrite power, sensorPower high. This line turns the sensory on the setting the output pin sensor to high. Delay is 10, and this line waits for 10 milliseconds to allow the sensors to stabilize. The val is analogRead sensorPin. This line reads the analog value from the sensor connected to the pin sensorPin AO and stores it in the variables val. digitalWrite sensorPower low. This line turns the sensor off by setting the output on pin sensorPower to low. Return val. The line returns the value stored in the val variable, which represents the current reading sensor. And overall, this code repeatedly measures the water level using the sensor and prints the reading to the serial monitor every second. The read sensor functions manage the sensor's power cycle, allowing for accurate reading.
The water level sensor, LED resistor, and Arduino Uno are connected as shown in the diagram. The Arduino Uno uses its built-in ADC to convert the analog signal from the sensor into a digital value that it can understand. The Arduino's code then maps this digital value to corresponding brightness level of the LED. For example, the higher water level might correspond to a brighter LED. To control the LED's brightness, the Arduino uses one of its PWM-capable digital output pins. PWM rapidly switches the LED on and off and varying the ratio of on time to off time creates the effect of different brightness levels. The Arduino takes an analog signal from the sensor, processes it, and outputs a digital control signal to the LED. By using PWM, the Arduino can control the LED's brightness, which is an analog behavior even though the Arduino primarily operates with the digital signals.
So the next is water level sensor. This sensor detects the water level and then outputs different signal depending on the detected level. Green LED indicates the lowest water level, and the yellow LED indicates the medium water level, and the red LED indicates the highest water level. ADA fruit liquid crystal. This code is used to control the LCD screen. ADA fruit liquid crystal LCD 10 initialize the LCD with an address of 0. The variable is int seconds is equals to 0. This variable keeps track of the elapsed time in seconds. LCD 1 begin 16 and 2 initialize the LCD with 16 columns and 2 rows. LCD 1 that print hello world displays hello world on the LCD when the Arduino starts. LCD 1 set cursor 0 and 1 moves the cursor to the second row, first column of the LCD. LCD 1 print seconds, print the current value of the seconds variable. LCD 1 set backlight 1 turns on the LCD backlight. Delay 500 waits for 500 milliseconds, half a second. LCD 1 that set backlight 0 turns off the LCD backlight. Delay 500, another 500 milliseconds delay. Seconds plus is equals to 1. This code increments the seconds variable by 1 to show the passing time.
Good day everyone, I'm here to present our activity about Arduino Uno connected to the LCD or liquid crystal display. First, we need to identify the materials that we need. We have LCD, 4 jumpers, Arduino Uno, and the cable connector. The jumper that we need to connect to the LCD on their corresponding slots, we have ground to ground, VCC to the 5 volts, SDA to the A4, and SCL to the A5. So, you will see on the code, we have the void setup. Yung void setup na may nakalagay na LCD.begin 16 and 2 bracket and LCD_1.print hello world. So, yung hello world natin, siya yung kailangan ma-print natin dun sa LCD natin at dapat yun yung makita nating output. So, the void loop naman siya, yun naman yung gaano katagal natin makikita yung hello world at gaano siya katagal mapiprint dun sa LCD natin. So, on the next video, we'll see how the implementation of our activity that we have.
GND is nakakonect siya sa GND ng Arduino, and then tong VCC is nakakonect siya sa 5 volts, Then SDA is nakakonect siya sa A4. And then itong SCL is nakakonect siya sa A5. Then itong water sensor, itong S is nakakonect siya sa A0. Tapos itong positive is nakakonect siya sa 3 volts. And then itong negative is nakakonect siya sa ground.
In a water level sensor system using Arduino, the LCD is used to visually display the water level or the other information. The water level sensors detect the height of the water and sends an analog signal to the Arduino. The Arduino reads the analog value and processes it to determine the corresponding water level. After the Arduino calculates the water level from the sensor, it sends instructions to the LCD to display information. The LCD in an Arduino-based water level sensor system is used to provide a real-time display of water level. The Arduino processes sensor input and updates the LCD with meaningful data and data for the user to monitor.
So, etong include wire H is nag-handle siya ng I2C communication, which is a two-wire communication protocol used to interface with devices like LCD. Liquid crystal naman is a library that simplifies controlling an LCD screen with I2C protocol. Then, this line is initialize the LCD object which represent the I2C LCD. 0x27 is the default I2C address of the LCD. This may vary depending on your hardware. And then itong 16 and 2 is represent the LCD dimension of the LCD, 16 columns and 2 rows. Then, itong water sensor pin is a constant that specifies the pin where the water level sensor is connected. The water sensor outputs an analog that will be read from pin A0. Then, void setup, LCD begins 16 initializes the LCD with 16 columns and 2 rows. And then LCD backlight turns on the backlight of the LCD, making it easier to read. Then itong Serial.begin 9600, nag-initialize siya ng serial communication at a baud rate of 9600, allowing you to monitor data using the serial monitor in the Arduino IDE. Then void loop, int water level, analogRead. Water sensor pin reads the analog signal from the water sensor on pin A0. The return value ranges from 0 to 1023, representing the voltage from 0 to 5 volts. Then next is map water level, 0, 1023, 0, 100, converts the raw sensor value to 0 to 1023 to a percentage to 0 to 100. This percentage represents how full the container is. Then LCD clear clears the LCD before displaying new data. LCD set cursor 0 and 0 moves the cursor to the first row and first column of the LCD. LCD print water level is makikita siya dito sa LCD. Then, LCD set cursor 0 and 1 moves the cursor to the second row of the LCD. And then LCD print water level percentage, print the calculate water level percentage. Then LCD print water level percentage prints the calculated water level percentage. So makikita siya dito kapag nilubog na yung water sensor. And then yung LCD print percent is adds percent symbol after the percentage value. Then serial this prints the water level percentage to the serial monitor, allowing you to see the same value on the computer via the Arduino IDE's serial monitor. Then itong delay na 5,000 is mag-aantay ka muna ng 5 seconds bago ulit mag-read yung next sensor naman.